Welcome everyone to the Python Exchange. My name is Cameron Riddell and I will serve as your host this afternoon. As you all may know, our goal is to have Python thrive within the National Lab system and associated research sites. And in support of that goal, today we are joined by Dan Yeaw, who's going to share his thoughts on bridging the Conda and PyPI ecosystems. Both tools and both ecosystems that I have used a lot over the last 15 years I've been writing Python code, so I'm very excited for this one today. For those of you who are unfamiliar with Dan's work, Dan is a senior engineer manager for open source at Anaconda, where he leads the team behind the Conda package manager, meaning if you've ever typed Conda into a terminal, there's a great chance that you have used Dan's work. Dan is also an active open source contributor through projects including GNOME, BeeWare, and Gaphor, and a longtime member of the Python community. He brings a unique perspective from his background in engineering, open source, and community building. So please join me in welcoming Dan Yeaw. In order to help us talk about some of the fantastic points that I know Dan is going to bring up and make today, we also have our team of host panelists who are going to help us drive discussion. For our team of host panelists, we'll have myself, James, Tom, and Max. And so that our audience can get to know each one of us, I always like to ask each member the types of questions that they are looking for to help today or where they find their expertise in their own background. So I'll kick us off. Hello, everyone. My name is Cameron Riddell, and I've been using Python for I would say a long time, but not a very long time. But I would love to have any questions related to computational or scientific computing, especially some of my favorite packages. We're talking NumPy, Pandas, SciPy, so on and so forth. And of course, can't forget Matplotlib, very near and dear to my heart. Let's also give our next host panelist, that is going to be James Powell, a quick opportunity to introduce himself. James?
Hi, everybody. I'm James Howell. I'm one of the host panelists. I work together with Cameron. I'm very interested to hear today a little bit about what makes Python packaging so much harder than everything else in the packaging world. I know Tom has some very specific comments about how the Rust people don't solve the hard problem. Well, I want to figure out what is the hard problem. Why does it seem to be so much harder for us than for everybody else?
Fantastic. And James, it is always have a pleasure having you here. You always ask such thought-provoking questions.
I always know how to provoke Tom.
Exactly. And next up, let's give Tom an opportunity to introduce himself as well. Tom?
I'm Tom Caswell. As I've been doing Python for well, also a long but not very long time. With my day job hat on, I've spent a lot of time deploying Python software with compiled extensions to a large fleet of machines produced by our users. And with my open source hats between Matplotlib and H5Py, I'm very much on the pointy end of building and distributing Python packages with C extensions. So I was around for the birth of Conda and the birth of Conda Forge. So I'm very interested in the current thinking of how to bridge the gap between the wheel ecosystem and the Conda ecosystem.
Absolutely. And Tom, I know that Dan will probably speak about this, but we'll absolutely be reaching out to you more about, wait, what? There's a difference, the wheel ecosystem and the Conda ecosystem. So I'm sure we'll have plenty of opportunity to get into all of that. Finally, we are also joined by Max. So Max, do you want to go ahead and give us a short introduction for yourself?
Sure. My pleasure to be here on this event for the first time as a panelist, but I've been enjoying these running events for a while. And I'm Max Rakitian, group lead of the data acquisition and detectors group of the synchrotron, which is behind me on the picture, and SLS2, which is on Long Island, New York. And I've been using Python for a good 15, 16 years at least. And I remember times when PyPI didn't exist and I had to install packages at that time on Windows using like standard Windows installers, wizards. And it was a bit clunky to install first numpy version. And I remember times of Python 2.5 to 6. So yeah, since then the community evolved a lot and improved, I would say. And there are like very good tools around. And I'm looking forward to see what then we'll talk about in terms of bridging the PyPI ecosystem and Conda ecosystem, and hopefully Pixie as well will be covered. So, thank you.
Fantastic. And Max, it's a pleasure having you up here as a host panelist instead of in the audience. And I do want to extend that invitation to other members of our audience. If you want to become a host panelist, if you want to have the opportunity to ask your questions live and on video, then please do send our hosts and panelists a message so that we can get in touch with you. But with all of that being said, why don't we go ahead and turn things over to our guest of the hour, to Dan Yeaw. Dan, I know that you have prepared some slides, or I should say, you'll probably share your screen with us. So you can go ahead and take over and share with us all of the greatness that you have for bridging the Conda and PyPI ecosystems.
Thanks so much. And yeah, thanks so much for having me. I'm really excited to talk about this today. So yeah, let's dive into bridging Conda and PyPI. Maybe before going off the side, in our logo here, we have a packaging platypus. He's crossing the bridge from Conda and Conda Forge ecosystems to the PyPI ecosystem, represented by a wheel of cheese. And if you weren't aware, that's actually what the wheel format's named after, a wheel of cheese, because the precursor for PyPI was called the Cheese Shop, and that's actually after a Monty Python skit. So, all right. So let's talk about this ecosystem split that happened. In 2012, Conda was created as a binary package manager to help install data science libraries. This is the era of pip version 1.2, Python 2.7 and 3.3. There was no binary format, so wheels didn't exist. And that's because PyPI was designed as a place to get Python source code, these source distributions, and install them with your other source code. Unfortunately, if you wanted to build a data science library, you had to bring your own compiler. And especially compiling Fortran or C on Windows was extremely challenging, extremely difficult. And that's why Conda was created to try to help solve those challenges. So because of that split, there really developed these two different ecosystems. Each made its own decisions based on the problems that they were solving for. So each part of the ecosystem has key differences. For example, whether to bundle binary dependencies or make them separate packages, or how solvers fundamentally work, or how metadata is stored both on the server and also installed for the packages themselves. And even how virtual environments work. There's a virtual env format in PyPI, and Conda has its own environment format. And I think this is actually like a big misconception that Conda and pip are actually more similar than they are. But what happens is most Conda users use pip in their Conda environments. And they do that because they need to fill dependencies that aren't on in the Conda ecosystem. Unfortunately, this often results in broken environments and users having to go through this really frustrating process of trying to figure out what this magical combination of Conda and pip dependencies are to get their project working. There's also this thing of pain of two package managers. Just having that means that users have to know what packages exist where, what they have to get from pip and what they have to get from Conda, and that can be really challenging. So why does Conda break, or why do Conda environments often break when you use pip inside of them? Once again, pip is not Conda, so you're using another package manager inside a Conda virtual environment. We try to do as best we can, but pip and UV use metadata. They store this metadata information about the installed packages in this site packages directory in the virtual environment. But Conda uses a centralized Conda meta folder for the environment, and it acts as a database where it keeps track of all the files that are installed and the information it needs to manage the environment. And since pip and UV install packages don't add this metadata to Conda meta, Conda can't fully manage them. This often causes state of the environment to get out of sync. And that normally happens when you go to install or update packages or remove something from the environment, and it breaks then. So it often doesn't break when you actually install the package originally. So that's also confusing because when things break is much later often than when you actually installed something in the environment. There's been lots of attempts to solve this. I think it all kind of breaks down into like two main categories. One I call strap on another tool approach. So Conda actually had a Conda pip sub command from the beginning, like 2 months after Conda was created, to help deal with this. And other package managers also deal with this as well. So I'm sorry, Pixie, if some of you are familiar with that package manager, also in the Conda ecosystem, uses UV under the hood to help get pip packages. But once again, users have to know what packages are available from where, from each ecosystem. And I think that's really difficult to have to manage that as a user. The second main attempt is called this package expansion approach. So we can do that by build more Conda packages, right? And Conda Forge has done a great job at that. These are community sourced recipes that 8,000 individuals have contributed to, and there's over 30,000 packages, which is amazing. But at the same time, PyPI packages have grown exponentially. As of today, there's about 860,000 packages on PyPI. And 610,000 of those are pure Python packages. So often a lot of effort is going into packaging these pure Python packages, which Conda wasn't its initial aim, right? It was aimed to fix this like binary package compatibility issue and not require people to build their own data science libraries. But Conda Forge is spending a lot of time just making recipes for pure Python packages. I guess this attempt is really hard to keep up when you have PyPI growing exponentially and the communities one by one adding package by package to Conda Forge. So let's take a step back. Let's create a blasting bridge. How would we bridge these ecosystems? And what would that look like? I think this is, for me, like what this blasting bridge would look like. And then we can go through like why that is and how we'd actually do that. So the metadata for PyPI packages are placed on a Conda channel, just like Conda packages. And the advantage of that is then they can be solved in a single step with the Conda packages as well. The next thing is all pure Python wheels on PyPI, not just some of them or a subset, like all of them are available. And then Conda packages are there to fill in those compiled dependencies that Conda is so good at. And the third thing is then native support in Conda to install wheels. A wheel is just a file format. So we can also teach Conda how to install a wheel just like it can install a Conda package. So let's talk more about that wheel format. A wheel is actually just a zip file. Here we can unzip it. And inside that zip file, and we're using this build library as an example. There's the source code. So you can see a few source files, these Python files. And then in this dist-info directory is the metadata for the package. Includes the license of the package. This key one here called metadata is the package metadata. The wheel is the wheel metadata specific to the build of the package. And finally, there's a record, which is a list of almost all the files in the wheel and their secure hashes. So you can see the wheel uses this dist-info format for its metadata. If we open that metadata file, you can see what it looks like. It's actually, this file format is the format for email headers, which is kind of an interesting format. And you can use the Python standard library email parser library to parse this format. And it's composed of key value pairs separated by a colon. So the key is, say, name, and then the value is build for this example. So there's some metadata up here, but some of the key things here requires dist is for each dependency of the package. So they're listed line by line. And as part of that, you can use things like conditionals. So that's like saying, hey, we're going to use import lib metadata greater than a version if our Python full version is less than 3.10. So this is like a conditional because we're saying if Python full version, then we want to install this dependency. You'll notice there's these keywords here. These are called markers, and they're part of the conditionals to differentiate, like, hey, I only want Colorama when the OS name is NT for Windows, or there's ones for Python version and Python full version. And these are here because, for example, Python 3.12 got a TOML library built in the standard library. So if we're in a version less than 3.12, actually, I think 3.11, it was added to the standard library. If we have a version less than 3.11, then we add Tomly as a dependency. Otherwise, we get it for free in the standard library. There's also these things called extras. These are optional dependency groups, and you can see them defined here. Hey, we add keyring as a dependency if we have an extra called keyring. And the keyring extra is defined down here. And you would install that by doing build and then brackets and then keyring inside of the brackets and then close the brackets. And so these are extra dependencies you can add that extend the library beyond its like core functionality. You can also get the same metadata off of PyPI directly. Here we're using a bit of Python and the URL lib and JSON libraries to open the endpoint for the JSON, and it's per package on PyPI. So you put PyPI / the package name / JSON, and you get a JSON payload back. And then we use Python to load the JSON. And then this data info here, this is a dict of package metadata. And then requires dist is a list of strings. Each one of them is this PEP 508 dependency specifier, which is this list here. So you can also get those same dependencies from this JSON off the web. And that's how when you're using pip or UV, it's able to know what the dependencies of the packages are installing without actually downloading the wheel and extracting it first. Okay, great. So then we have a Conda package format. Let's see how that's a little bit different. It also happens to be a zip file. So it has a .conda extension. You extract that zip file, and it's a little bit different. The two main parts of it, there's package and info. Package has the actually built library that you've built, and info is the metadata. And they're both compressed using Z standard compression into a tarball to save space. If you extract then the metadata out of the info tarball, you can see it goes to an info directory, and all the metadata are in JSON files. So the format's a little bit different. And then there's also this recipe here, which is a reproducible recipe to rebuild that library just as it was built in that package. If we want to see what the metadata looks like, this index.json is the main metadata file. And it's not too much different from what we saw for the Python metadata file, except yeah, it's a little bit different format. And here are the dependencies here. So you can see depends on Python and Colorama. One thing you can notice is Conda doesn't currently for Conda packages, and they're adding support for this, and we needed it for this as well. But you can sell like there's no conditional or extra dependencies here. So remember, Colorama was only needed for Windows, but here we're adding it as a dependency all the time in Conda packages as an example. And if you wanted an extra, like the UV extra or the keyring extra, it doesn't exist here, right? That would be like a different package if we wanted to add that. All right, just like PyPI, we can also use a JSON endpoint. One main difference, though, is instead of a file per package, we have something called repo-data.json, and it is a single metadata file for all packages on the channel. This file can get pretty big. You imagine Conda Forge has 30,000 packages and every version of all those packages. Those files can get up to hundreds of megabytes. So here we can put in the channel Conda Forge. NoArch is the pure Python packages. It doesn't have an architecture. In other words, it's not a compiled package. And we can get the max version for the packages with a name of the package we're looking for. And we would pass in like python-build at the command line to get the pass in the package name. And then we can print the dependencies. And so it'll get the latest version of python-build and then print all the dependencies, just kind of like we showed in the JSON file. One thing to notice is this package is now called python-build, so the name's not the same as PyPI. And that happens sometimes because Conda is a multi-language package manager ecosystem, and a name like build is fairly generic, right? So for the Python ecosystem, there's probably just there's just this one build library. But if you name something build in Conda, it's not very specific. So often things are renamed to python-build as an example. And we know that's like a Python library. And that'll be something we need to deal with as we create our bridge. There's also file hosting differences. So PyPI simple index, each package is an own directory. So the package name here, build, and then all the wheels and source distributions for that package are in that directory. And also their file locations are hosted on a CDN. So your actual download URL is this long string with seemingly random hash here in front. And this is a Blake2 hash of the directory it's in and a SHA-256 hash of the file. So you could actually look at the URL and check that the file was the file you were anticipating to download using the URL alone. For Conda channels, all the packages are just in a flat directory. So everything in the channel, all those Conda packages will just be in the same directory. So that's something we have to account for too, having kind of this nesting on PyPI and having a flat directory on a Conda channel. It's also mostly assumed that all the packages, we might use a CDN in front of a channel for Conda, but it's assumed like for the most part that all the Conda packages are served right in the same directory as that repo data metadata we talked about. All the channel is together. So I kind of hinted at this a little bit. This shows a few challenges for us to overcome if we want to build a bridge. So our metadata is different. It's stored in different formats. We looked at, the email header format. We looked at JSON, different syntax and names for things, Python_version versus just Python. There's also a difference in feature parity. Conda didn't have this notion of conditional dependencies or these extras. So those are features we're going to have to add to Conda if it's able to fully speak what PyPI does. And finally, the packaging name differences. So build versus Python build, or PyQt5 on PyPI versus PyQt on Conda. So there's these two ecosystems have some differences in package naming. So we're going to have to deal with that as well. All right, so I think we can do this. Let's take repo data. This is what repo data looks like for the build package. Just a small snippet of the full repo data.json. And then how would we add repo data for a wheel? And remember, we want to do this because if we can put the wheels in the same repo data, then our solver can solve both Conda packages and wheels in one step, and it's all together. And we can treat the wheel just like any other package. All right, so first of all, we need to add some like backwards compatibility guards. So we can add this key called v3. This is like a version of repo data. because we don't want an older version of Conda or Mamba or other Conda sealed, clients to see a wheel and not know how to handle it and then break your client, right? So we can add this v3 key, and then if a client doesn't know how to handle it, it'll just ignore that repo data. We had packages.conda, so we'll add a new key as well called wheel, and that will say, hey, these are wheels in this section. The next step is the package identifiers for Conda packages are in this form of name, version, and build string with a file extension. And this is important because in order to parse this amount of repo data quickly, we do something called sparse repo data parsing, and able to send the solver the name and the version of all the packages without parsing all the repo data. You just want to parse the names and versions. So it's actually the key, and then you don't have to parse all this stuff below that. And with this amount of like JSON, you want to have all these like small optimizations, right? So we have this wheel file. It's in a little bit different format. So it has a name, it has a version, and then it has these things called platform compatibility tags. We're going to be dealing with pure Python packages. So they're mostly in this py3 none any as their platform compatibility tags, because they don't have things like compiled extensions. And then there's a file extension on the end. Okay, so we need to first map the name. So this is also a JSON mapping where we can say the PyPI name is build and the Conda name is Python build. And then every time we get a wheel like build, we can rename it to Python build. We also changed in the build string here, or I guess these were platform compatibility tags, but we're turning them into a build string. We changed them to underscores because the clients expect that the build string doesn't have dashes in it, because the separators between the name, the version, and the build string are all dashes. And if you add more dashes in, then you confuse the clients that are trying to parse those build strings. Okay, so then finally, we add a URL. So this is where we're going to download this wheel from. And you can see that we now have the key to our package is the name, version, and this build string. And we have a URL where we can download the wheel from, so we're doing pretty good. Notice we also remove the file extension. The reason the Conda packages have a .conda, it's the actual file name, but because we couldn't use the file name as the key, because we had to change the name to do the name mapping, we remove the file extension so it doesn't look like a file name, because this is not the file name anymore. The file name is still the build dash, .wheel. Okay, and next we do marker conversion. So we mentioned that some of the markers are similar but have different names. So in PyPI, it's called Python underscore version, and Conda is just called Python. So we can just map Python underscore version to Python. Other markers can be converted, like in PyPI world, we have something called a platform system. In Conda, we use what's called a virtual package, and these are these underscore and then the platform names. And that's how you are able to designate that a package is only for a single platform. We can also do some partial mapping for things like sysplatform. We don't have Win32, but we can say like, well, Win32 is not equal to the Unix virtual package. So there's like some partial mapping of some of the markers we can do as well. All in all, there's about like 10 of these markers, so we need to map them back and forth. Next is the conditionals and extras. We actually added support for this, and there's a Conda enhancement proposal that's about to be well, actually, it was just approved. So there's 2 Conda enhancement proposals that are approved standards now in the Conda ecosystem. So we can start using these features in Conda even without this Wheels project. But a conditional, once again, is something like if Python version is less than 3.11, then we want this dependency. This is called a match spec. It's what Conda uses to define what package you want. So you could enter something like this at the command line too, to say, hey, I want some version of a package and this build string or something. So we add in the brackets here this win keyword, and that's the conditional. So we say when Python's less than 3.11, then we have this dependency. We also add extras. and they're called extra underscore depends in our repo data. So we can add those also as extras as well. All right, so we added the backwards compatible v3 tag. We did the package name conversion in the package key and stripped off the file extension and normalized with the format there. And now you can see like here's the dependencies. We have those conditionals that were added. So now Colorama is only on Windows as an example, right? We also have these extra dependencies for keyring and UV, and we finally pointed the file the file URL to the CDN for PyPI, so we can directly download from PyPI instead of hosting the wheels ourselves. All right, so this repo data can be posted just like all the other repo data, and then we give this to Conda or another solver, and it's able to solve a complete solution using both Conda and PyPI packages together. Now that we have this solution using Conda and PyPI packages, we can then download and extract the wheels. That's pretty easy to do with Python. So we can create this path of the wheel file and then unpack it using this the zip file built-in module, and then extract it all to wherever we need to unpack it from. So we can do that with Python, no problem. This is how we actually natively support wheel extraction. So first is like stage A, which is this first section here. So we see this wheel, which is a zip file, and we extract this wheel to a package cache. In order to do that, we created a plugin called Conda PyPI, which calls this extract wheel as Conda package method whenever it encounters a wheel. And then we used the installer library, which is from this PyPI ecosystem, and created this custom MyWheelDestination class along with it. And then we take the payload files and extract them into site packages, and the package metadata is written to the info directory, and then that is all in this package cache. The reason why we do that is because it's much more efficient to put all the files and extract them once in this cache, and then if you reuse the same packages in multiple environments, you don't have to re-extract them. Instead, in the next step, we can just hard link and copy the file, or copy them if you don't have hard link available, to where they need to go in the environment. So that's stage B. So we link them into an environment and then register them in Conda Meta, which is once again that environment database. So files in this package cache, are hard linked and copied into the prefix, either in a lib Python version site packages directory or a bin directory. And that goes into this called the environment prefix. So we copy them in there. And then we create this prefix record of them and copy this prefix record into Conda Meta. So this is once again that list of all the packages that exist in the environment. And so that lists every linked file, passes the metadata, links the source, the repo data record. Once again, this is like Conda's central install database, so it knows where all the files are and knows what's installed, so you can update and remove things. All right, so we have native support for wheel extraction. We can extract a wheel just like we can a Conda package. I talked a little bit about this plugin called Conda PyPI. We also use a library called Pluggy. It's actually was created initially for PyTest, and some of you may be familiar. PyTest has plugins that you can install. This is very similar. You add a decorator on a function, and that signifies that this is a hook for a plugin. And then we create this generator, and anytime what this does is registers that this wheel file extension is a valid file extension and hooks up this package extractor to it. And anytime we need to extract that package, then this function extract wheel as Conda package gets called. So that's kind of how we register this plugin hook and make it an optional thing if someone wants to install this plugin. It makes Conda very extensible. All right, so we added the repo data. We added the new features, did name mapping. We taught Conda how to natively install files. So now we can do Conda install package, and that package could be on PyPI or CondaForge, and it will just install them in one install together. Let's show a demo of that. So at PyCon, someone stopped by the booth and they work on a library called qplots, which is a plotting library, and they converted from C++ to Python. I think they used an LLM to help during the conversion. But he showed up and said like, hey, I want to package this for Conda. It's on PyPI right now. How would I go about doing that? And I think often this is what people run into, and we'll go through the demo, is they create a Conda environment. So maybe you create one called qplots, and then you try to Conda install, you activate the environment and try to Conda install a package to it, not knowing that it's not on Conda already. And what do you get? Not a very good experience because you didn't know it wasn't in Conda. So you get a package not found error. So we try to install this pyqplot. That's what it's called on PyPI. So it says packages not found in channels error. And then what do most people do? Well, it's not there. Maybe I can pip install it, right? And we talked about all the things that go wrong with that and break your environment later and stuff like that. So instead of pip installing it, let's do something else. So we one time configure an extra channel. So let's add a channel called Conda PyPI. This channel has 610,000 pure Python packages in it. And then we're also using this solver called Rattler that's in beta. It's actually the Rust solver that Pixie uses as well. Okay, and then let's try to install pyqplot again. And now it worked. So you can see pyqplot right here is obtained from the Conda PyPI channel, and most of the other packages are all of CondaForge, and then it did one solve altogether and installed the package. So the person who came to the booth at PyCon didn't need to necessarily, they could, but they didn't need to package their package for Conda. It was already available if we're using this channel, right? So I invite everyone to give it a try. You can go to the Conda docs, new features, and the instructions are there. But it's pretty much what I just showed you. Add a channel and then configure your solver, and you can go ahead. The name mapping is set up. This is kind of community oriented. It is set up to name map to CondaForge. If you wanted to use it with like defaults or like Anaconda's main channel, the main name mapping it would probably work for most things, but the name mapping for a few things would probably be off a little bit. So it is designed and works best with CondaForge. And that's all for my presentation. Yeah, happy to answer questions and happy for the discussion now.
Amazing. Thanks so much, Dan. That was absolutely wonderful. And I love the demo at the end to tie it all together. Let's go ahead and jump into our discussion. If you are in our audience and you have any questions, please go ahead. You can enter them into either the Q&A widget or the chat widget. We'll be monitoring both to make sure that your questions get answered. But while those questions come in, I'd love to turn it over to our host panelists. Host panelists, any questions or comments to get our discussion started?
I'm super stoked this exists. And just to be clear, you don't map the binary wheels. You only do the non-any wheels.
Yeah, so it's just the pure Python wheels. And I think that really like works on the strengths of Conda, because Conda is like a great format and its strength is really those binary dependencies. And one of the reasons why that's so strong at that is each binary dependency gets installed as a separate package. And generally wheels, if they have binary dependencies, get built all into this fat wheel with all its dependencies. And that creates a lot of problems because say there's a security problem with one of your dependencies. Well, now you have to update not just the dependency, but you have to update all the users of that dependency and release all new wheels and stuff like that, right? So I think capitalizing on Conda strengths for binary dependencies is really good, but then also being able to use all these 600,000 pure Python wheels in your projects together, I think really kind of uses the best of both together, right? So
That's very powerful addition to the community. And I remember myself trying to repackage pure Python packages with Conda Forge. I went to the stage recipes repository, submitted the PR, waited for maintainers to wait until it's done. And yeah, just for the sake of getting the same package in the single Conda ecosystem, that was a lot of efforts just to, yeah, in terms of time and waiting. This is a great addition. We should explore it more for our production.
yeah, definitely.
Yeah.
We do have a question in the chat about licensing, or I should say licensure. This individual is curious about what are the Anaconda license implications for using this?
Yeah, so Anaconda currently requires users to agree to our terms of service if you're using like the defaults or main channel. Um, and it happens to be free if you're using it for personal use or you're at a company less than 200 employees or like you're at an educational organization, then it happens that the terms of service are, well, it's free for you. But if you're not, then we make money selling access to enterprises, right? In this case, this isn't actually on the main channel or defaults. It's a completely separate channel. And so this channel is designed to be the community focus is designed to be used with Conda Forge. And yeah, you don't need to agree to terms of service. It's not, there's no license implications. It's free to use. So yeah, everyone go try it out. There's no, you don't have to agree to uh, terms of service, and you could use Mini Forge, which by default uses Conda Forge, and add this channel when you're not using really any Anaconda thing. So
The follow-up based on the kind of the qplot story that you shared. What is a bad takeaway from this to say, oh, look, I can just upload things to PyPI and Conda will get them at some point. So now I never need to bother making another feedstock or Conda recipe again.
yeah, so I think one thing that's going on right now is I mentioned these Conda enhancement proposals, and we just released ones for conditionals and extras. There's also draft ones that have that are there's actually like three to go along with it for this wheel support to make it a community standard. I would really love to see that one, this becomes community standard. And the reason why this is mapped to Conda Forge is because I'm part of the Conda Forge community as well. And with those 30,000 plus packages, I think around half, like 16,000, are just pure Python packages. And if you go to how Conda Forge gets new recipes accepted is through a repository called Staged Recipes. So you create a new recipe on a fork of Staged Recipes and you submit it, and there's a large backlog of people waiting to get their recipes reviewed. And that's just kind of like we've reached a limitation of Conda Forge a bit of like free volunteer folks being able to review all these recipes coming in, right? So there's quite a backlog. And I think this could be like a real benefit for the community if we could spend less effort creating, updating, maintaining pure Python recipes, and instead be able to focus more of our attention on all those like compiled packages and libraries that I think are like really Conda's strong suit. No one has to be like concerned. None of those feedstocks and recipes are going away immediately or anything like that. In fact, like you could have packages in the Conda format and the wheel format together on the same channel, and they'd work fine, and yeah, they can be used together. So it's not like we have to make an immediate transition, but at least I envision it'd be really powerful if we could reduce kind of maintenance burden on the Conda Forge community by just making all these pure Python packages more automatic and just you get all of them from PyPI.
I click merge on probably one or two pure Python like no arch packages and Conda Forge a week. It'd be nice not to get those notifications.
Yeah, exactly. Yeah, and even yeah, you're able to do a few, other folks are able to do a few, and those are like really great contributions. But imagine if we could just like stop that or something, right?
Yep.
To not have to do that work anymore. So yeah.
Just like the CI and churn of the Conda Forge bot creating and running, you know, the CI job twice per thing because like once per PR like there's
Yeah. Yeah, that's another point of like the resources that we use in CI or continuously updating all those recipes and people still have to manually like approve and review the recipe updates and stuff, right? So yeah, it's a lot.
Are the new packages automatically added, or we need to do something to incorporate them? For example, I release a new package for my beamline somewhere, and I want it to be available through Conda. What's the process for this?
Yeah, so the current channel as of today was a batch import of everything in PyPI, but in the next like week or two, it's going to be real time. So the team that helps maintain our Conda channels at Anaconda is going to ensure that any new package and any updates to package are near real time, less than an hour or so from getting on PyPI. Then that new package appears on the channel, or if someone adds a new package for the first time, it's on the channel as well. So it'll just kind of be automatic.
Pretty cool. Thank you.
I'm curious, since you shared kind of a lot of like how this work was done, what would you say was the hardest step to get right in order to make this bridge actually work?
So I think the hardest step is always every time the community work that needs to be done, and we're not done with that yet because it's not a community standard yet. But I think that's also like the most fun and rewarding work of working with others in the Conda and Conda Forge community and like talking to them about things we've tried and what possible solutions. This also wasn't, yeah, there's a saying of like built on the shoulders of giants. Like I kind of just said, hey, everything's been tried in these two categories, but there was lots of little incremental things that people created. So like the Conda PyPI plugin was created a few years ago by Jaime Rodriguez, and it had a pip sub command. And then some folks at Anaconda tried patching repo data in a very hacky way and got it wheels to solve from it. And Daniel Holt created another package called Conda Pupa that was like real time converted wheels to Conda packages on the fly. So like all these like little tiny efforts over time, we're all like, oh, hey, if we did this in a like an ideal way and made it a community standard, it was kind of like bringing all those types of like pieces together. So yeah, definitely hats off to all the work that's been done in the past from the community. And there's still lots of work to be done to get everyone to like, we talked about, hey, this could be really beneficial for Conda Forge. We need to make that happen now as like a real thing of people are trust it and it's a community standard and we can stop building so many Conda Forge packages. So
I'm also curious because I know you can specify or at least install pip install packages via Pixie as well. And I'm curious, how does this approach differ if you're familiar with what Pixie does under the hood?
yeah, so I mentioned like the two approaches. So this is the sounds like a little negative. It's not meant to be negative, but they took the strap another tool on approach, which is totally fine. And like I said, Conda did that from the beginning as well and had a pip sub command. So they're using UV under the hood. Then I think in general that works really nice with Pixie, and Pixie is very fast, and so is UV. So using them together is very fast. However, it has to do they're like the two downfalls of that approach or the negatives of that approach is you have to do two solves. So Pixie first tries to solve all the Conda packages, and then it has to go back and try to solve all the UV packages, and it could be faster if it could just do it all at once. Um, and then the second thing is, as a user, you have to know what's still with Pixie, you have to know what's on PyPI and what's on Conda Forge. So when you do like Pixie add, you have to put a dash dash PyPI flag, right? And you have to know where it's coming from. And I think for like the average user, I think we rather not. Like I don't care. Like just I want to install things. I don't care what package format they're in. And obviously, if you're in a more like secure environment, you may care exactly where each package is from and the security posture and stuff like that. But for like the average user just doing like a data science thing and hey, there's Conda Forge and PyPI and I could get packages from both, that's perfect, right? So, and not having to worry about trying to get the right combination of pip and Conda working together, yeah, it's really powerful and
Yeah,
much
then
easier. So.
you end up with, oh, well, just add dash dash PyPI. It's the thing that'll make it work, and it'll always work. And then you're wondering, wait, why do I ever do this without dash dash
But
PyPI?
it won't always work because sometimes you'll get a binary wheel and everything will break. Um,
Yep.
so thinking a step ahead, if the idea is to start dropping pure Python feedstocks, if I have a compiled feedstock that depends on a pure Python package, could we get to a world where we can drop those from Conda Forge as well? Or will like the Conda package always have to have like a pure Conda set of dependencies? And then if you build an environment with some pure wheels and some Conda packages that it will work. Or did my question?
I think I understood the question, but if not, please correct me. So I think your question is like, hey, you have a compiled Conda package, some data science library, and maybe it depends on pure Python libraries. Um, I guess our build tools, yeah, Conda build, for example, or Rattler build, um, don't really care where the package is coming from per se, or like what format it's in. So as long as Conda can get that dependency and it's all in repo data and understand that, hey, I have a wheel here, and I can extract that as well, then it's total like the build tools actually don't care at all about that. So you could have a compiled dependency and it depends on lots and lots of pure Python dependencies, and none of them could be Conda recipes on Conda Forge. They could just all be directly on PyPI. Or maybe this Conda PyPI channel is actually like part of Conda Forge. Maybe that's even like a sub channel of Conda Forge, like Conda or something like that, right?
Or you get PyPI to host the repo data.
Yeah. There's actually been discussions about that exact thing. Durbin, who used to be one of the PyPI like director of their infrastructure, brought that up actually like a year and a half ago. And I brought it up again with them at PyCon, just kind of like mentioned it. They're not opposed to doing something like that. So that could be an and actually talking to them like it doesn't even require some like community standard or like PEP or anything like that. So that could also be an option. Like PyPI could host its own wheels Conda channel. Yeah, effectively, right? I think like to get it started and going, Anaconda has the know-how to build this channel. It also uses a technology called sharded repo data because that repo data file is so large because there's so many packages, that single file would be 5 GB, and no one wants to, yeah, no one wants to wait. I mean, it's just that your computer couldn't process that much metadata, and no one wants to wait for that. So that was also another technology. Once again, we're building on all these like incremental improvements in the ecosystem, and Pixie and Conda and Mamba support sharded repo data now, which just downloads little tiny shards of package index rather than all of it, and lets you do the solve without getting all the metadata. So that was also a key enabler as well. So
I'm very excited about this.
yeah, awesome. That's great.
Tom, what do you think your first application of this is going to be in terms of either your work or open source?
Um, I mean, we have a number of packages at BNL where we, they're pure Python, so like Blue Sky OFID, that flavor of things. The PyPI's trusted publisher GitHub Action is very good at what it does. And so it's very easy to get an automated pipeline that goes and pushes it up. And then we then have, a 6 hour to 1 day lag to getting the Conda Forge package updated as well, so we can use it. In principle, we've switched to using Pixie as our main driver, mostly to get the lock files and that tooling around it. We could start pulling from PyPI, but then once you do that, it's very hard to ensure you only pull pure wheels, right? Once you start running the risk of pulling a binary wheel, like you accidentally get PyQt from both PyPI and Conda Forge, A, you burned a lot of space, and B, it's going to segfault eventually. So that's a high risk. We'd rather do the delay. But if we can get to a point where we just say blue sky and it knows to get the pure wheel, that would make some of our close, how quick it takes us to go from we have a fix, publish, release it, get it on the floor, ready to go. That loop would be closed nicely.
Yeah, we'll mention, so Anaconda has a partnership with Prefix, and I talked to Wolf quite a lot. And I can't make promises for him, but we've at least been in discussions. Once again, I want this to be like a community standard. And I would love for Pixie to also implement support for this. The reason why you need the Rattler solver is because of support for conditionals and extra dependencies. We're able to work with them to implement it there first and understand the wheels repo data and stuff, because we can make changes with prefix much quicker to Rattler than the other solvers, so the classic one or libmamba. But also I think it'd be amazing if Pixie could also support natively installing wheels from repo data just like this as well. So I don't think it has to be a Conda unique thing necessarily. So
It's I would say that I've made feature requests to prefix for both the ability to ban binary wheels from their Pixie solve, or to make it the option that, like, when you say please install this package, it will refuse to install any dependencies from PyPI unless you explicitly ask for it. And I've not gotten have not either not I've not gone down the rest myself, and I've not got anyone excited enough to do it, but it sounds like this solves that problem by only doing the pure wheels and then just folding itself in.
right, exactly. Yep. And also like things like your pixie.toml, like we talked about the command line arguments, you don't have to add that. You wouldn't have to add dash PyPI, and like your pixie.toml would also be simpler because you wouldn't have these PyPI sections at all. You would just have a list of all your dependencies, and then the solver picks the best one based on the solve it's doing, right? So it also simplifies even your config files and stuff.
Speaking of the CLI, now that you mentioned it, will there be support, or is there support for specifying extras in this Conda CLI, like with the square bracket syntax, like you can with pip?
So we in Conda 26.5 we added like initial support. That syntax is called match spec, so we added initial support for that, and then I think we're about to release a new version of Conda right now this week, and then also Conda PyPI added support for better making use of those extras, so like an enhancement from what it had before. So I think like probably like the next version of Conda, it should be pretty able to use extras. The thing that needs to come with a REST ecosystem though is if we're uh, your packages in your repo data have to have that information. So in this case, the wheels have it because we needed it, but we're also starting to add support to the build tools so that you can say like, oh, hey, this V1 recipe or something has extra support, and I want to build it with that support, and then that'll show up in that V3 repo data, whether or not you're using wheels or Conda packages. So the whole Conda ecosystem will benefit from having extras and conditionals. So yeah, it's good.
Absolutely amazing. Well, that brings us to the end of the time that we had for today. I want to thank everyone in our audience for coming. It has been an absolute blast. I want to thank all of our host panelists and our guest, Dan. Thank you all so, so much. I want to encourage everyone in the audience to keep an eye on our website for not only a recording of today's session, but also an announcement for our next upcoming session, which will be next month on the last Wednesday of the month. We'll be joined by Darhas Botina from Open Teams, and it should be a great time. So stay tuned with our website. That's meetup.doepy.org, and we'll see you next time. Thanks, everyone. Have a great rest of your day.